Hey guys, welcome back to my YouTube channel. This is Namita from Information Science and Engineering Department studying at Sri Venkateshwara College of Engineering. So the topic of today is mean variance and standard deviation from mathematical foundations for computing, probability and statistics. The overview of this video is introduction, what is mean, calculating mean, variance, calculating variance, standard deviation, calculating standard deviation, and their applications of mean, variance, and standard deviation. Introduction. Welcome to my presentation on mean, variance and standard deviation. These statistical concepts may seem daunting at first, but they are essential tools for engineers in a wide range of fields. Whether you're working on designing a new bridge or developing more efficient manufacturing process, understanding these concepts can help you make better decisions and achieve better outcomes. So let's dive in and explore the world of statistical analysis of engineering. What is mean? Mean is a statistical measure that represents the central tendency of a set of data. In engineering applications, mean is used to analyze and interpret large amounts of data to make informed decisions. For example, in civil engineering, mean is used to calculate the average strength of construction materials such as concrete or steel. This information is critical for ensuring the safety and reliability of structures. Another example of mean in engineering is electrical engineering, where it is used to calculate the average consumption of electric devices. How to calculate mean? Mean is calculated by adding up all the numbers in the set and dividing them by the total number of values in the set. For example, if we have a set of 5 numbers 2, 4, 6 and 8 and 10, we would add them up and then divide by the total number of values, that is by adding all these numbers we'll get 30 and the total numbers here present are 5, so 30 divided by 5 will be 6. Therefore the mean of this set is 6. This is the formula. What is variance? Variance is a measure of how spread out a set of data is from its mean. In engineering, variance is used to assess the performance and reliability of systems. One real-world example of variance in engineering is the measurement of wind speeds. Wind speed measurements can vary widely over time and across different locations. By calculating the variance of these measurements, engineers can determine the most suitable location for wind turbines and predict their power output with greater accuracy. How to calculate variance? The formula for calculating variance involves several steps, but it's not too difficult once you understand the process. To calculate variance, first we have to find the mean of the data set. Then subtract each value from the mean and square the result. Add up all the squared differences and divide by the number of values in the data. This will give you the variance. And this is the formula, and the second one is the formula for grouped data. What is standard deviation? Standard deviation is a measure of the amount of variation or dispersion of a set of data values from their mean. In simpler terms, it tells us how spread out the data is. In engineering, standard deviation is an important tool for quality control and process management. For example, in manufacturing, engineers use standard deviation to ensure that products are consistent and meet specifications. If the standard deviation is too high, it means that there is too much variation in the product and adjustments need to be made to production process. How to calculate standard deviation? To calculate standard deviation, we first need to find the mean of the data set. Once we have the mean, we can then calculate the variance. Finally, the standard deviation is found by taking the square root of variance. That is, first we'll have to be finding the mean and then variance, and then using the variance we have to square the variance and we'll find the standard deviation. It is important to understand how to calculate standard deviation as it is the key measure of variability in engineering applications, helping engineers to identify patterns and trends in data. This is the formula. And then engineering applications of mean. In civil engineering, mean is used to calculate the average strength of materials such as concrete and steel. This is important for ensuring that structures are built to withstand expected loads and stresses. In electrical engineering, mean is used to analyze power consumption data. By calculating the mean power usage over a period of time, engineers can design more efficient systems and reduce energy cost. Engineering applications of variance. In civil engineering, variance is used to measure the variability of materials properties such as concrete strength or soil stiffness. By calculating the variance, engineers can ensure that the materials used in construction are consistent and meet design expectations. In mechanical engineering, variance is used to analyze the reliability of mechanical systems. For example, by calculating the variance of stress or strain measurements, engineers can determine the likelihood of failure and make design improvements to increase safety and efficiency. Engineering applications of standard deviations. In engineering, standard deviation is used to determine the reliability and consistency. For example, in civil engineering, standard deviation is used to ensure that concrete mixtures meet the required strength specifications. By measuring the strength of concrete samples, engineers can ensure that the mixture is consistent and reliable for construction projects. In mechanical engineering, standard deviation is used to evaluate the performance of components and systems. In the automotive industry, it is used to test the durability and reliability of engines and other mechanical parts. Conclusion. In conclusion, we have learnt about the fundamental concepts of mean, variance, and standard deviation and their significance in engineering applications. Mean is used to represent the average value of a set of data points, while variance and standard deviation are used to measure the spread or variability of the data around the mean. We have also seen how the concepts are used in various engineering disciplines such as civil engineering, mechanical, and electrical engineering. By understanding these concepts, engineers can optimize designs, improve processes, and ensure safety and reliability in their projects. Therefore, it is crucial for engineers to have a solid grasp of these concepts and their applications. Thank you.